everybody, I'm Shannon Swilley Greco at the Princeton Plasma Physics Lab. Most people, when they think of plasma, they don't think that they've seen a gazillion plasmas in their life, and they definitely have seen plasma many, many times in their life, but a lot of times they think of this. This is a plasma ball. And it's almost exactly the same thing as lightning, which lightning is another plasma. See, I told you you'd seen a lot of plasmas. What is plasma? It's the fourth state of matter. We've got solid, liquid, gas, and we've got plasma. Here in this box you can see, so this plasma is going all over the place, but when I touch it, it follows my finger. So why does it follow my finger? It follows my finger because it does have something to do with electricity. The electricity is moving through that plasma. The electricity is what's giving it that extra energy to turn that gas that's in here. Actually, we can turn it off. Now it's gas. Now it's plasma. Now it's gas. Now it's plasma. That electricity is turning the gas all along the path of the electricity into plasma. So those glowing little tendrils of light are the plasma. That electricity wants to follow a path to the ground. And so when I touch it on the side with my finger, it provides that path to the ground. When I touch it on the side, it's very, very jumpy. When I touch it on the tippy top, look at how much more stable that is. And the reason is hot air balloons. It's a very similar concept to hot air balloons. When a gas gets hot, it expands, and when it expands, it becomes less dense. The same amount of stuff is taking up a bigger amount of space, so there's less stuff in that same square of space, that cube of space. And so as it gets less dense, it tends to rise, like a balloon floating on the surface of a pool or a hot air balloon. You heat up that air in that balloon and it rises and it goes up. So you see the plasma tendrils, they're all jumpy. So they want to play with something. These charges want to interact with other charged particles. While the charged particles and the electrons can't actually pass through the insulator of the glass, they still want to play with some source of charges. And your body is a conductor, and it can couple with the electric charges in your body. When I touch it on the side, it's all jumpy because it can't decide if it wants to play with the charges in the conductor nearby or if it wants to go up. It wants to get rid of those charges it's building up. Charges are building up in something and it wants to get neutralized.